Alright, so today we're going to be doing 115, which is going to be solving linear inequalities. So a linear inequality is similar to a linear equation, only instead of equal signs, we use inequality symbols, such as less than, greater than, less than or equal to, greater than or equal to. So first thing we're going to talk about is how you can use points to determine if a point satisfies an inequality. So to do this, you're basically just going to take your inequality and plug in the x and y value that was given to you. So I'm going to take this and plug in x and y. That's going to give me 4 is greater than or equal to negative 2 times x, which is 7 in this case, plus 9. What is negative 2 times 7?
Negative 14.
Good. So we have 4 is greater than or equal to negative 14 plus 9. What is negative 14 plus 9? Good. Is 4 greater than negative 5? So this is true. So you're going to have to determine if the statement is true or false. So let's try the next one. So for this one, we're going to be plugging in for x and y. That's going to be 3 is greater than or equal to negative 2 times negative 1 plus 9. That's 3 is greater than or equal to 2 plus 9. 3 is greater than or equal to 11. Is that true or false?
False.
Good, that one's false.
You write it to your app.
Sure. It's your notes. Whatever works. Anyone have any questions about that? Okay. Next one. Negative 5 is greater than or equal to negative 2 times 10, which is our x, plus 9. Negative 2 times 10 is?
Negative 20.
Good. Negative 20 plus 9?
Negative 11.
Good. Is negative 5 greater than or equal to negative 11?
Yes.
That is true. So does anyone have any questions about this concept, checking inequalities? Okay. So let's go ahead and try graphing. So, graphing linear inequalities is a visual way of showing all ordered pairs that satisfy the inequality. So step 1 is to write the inequality in slope-intercept form. Step 2 is to graph the boundary line. So this is really important. Your lines can either be dashed or solid based on the inequalities. So if you can't see what I'm saying, you have a copy of this too, but basically if you use a less than or greater than sign, you use a dashed line. And if you use a less than or equal to, greater than or equal to sign, you use a solid line. So that's going to determine on your graph which line you use. So when you're doing dashed, you're doing it in pencil and all that, so just do your best with making it look dashed, okay? And then step 3 is going to be to pick a test point to determine which region should be shaded. So typically you want to try 0, 0 or 0, 1. Now I'm also going to show you another trick on how to tell this as well. So this is just a backup option. When we say slope-intercept form, we mean in the form y, and then whatever inequality is going to go in this box, mx plus b. So this box is going to be an inequality. Bless you. So it's very similar to y equals mx plus b form for linear functions, but the difference is we're dealing with inequalities here. Okay? So is everyone ready to try number 1? All right. So the first thing you look at is this in slope-intercept form? For number, it's not really number 1, it's number 2.
Yeah.
It is in slope-intercept form. I have y, and then I have some inequality, some value for the slope, and then x, and then the y-intercept. So the first thing you always graph is the y-intercept, which in this case is at negative 1. And then from here, you're going to go up 2 units and to the right 3 units, because that's your slope, rise over run. So is everyone good with how I got those 3 dots? Just graphing the line. Now here's where the inequality part comes in. We have to determine if this is going to be a dashed or solid line. What do you think based on the inequality here?
Dash.
Good, it's going to be a dashed line because there's no equal sign under the inequality symbol. And now we have to determine if we're going to shade above or below this line. So, there are 2 ways to figure this out. I'm going to show you both for the first problem we try. So, basically you can think of the inequality sign as a little alligator mouth, okay? If the alligator is eating the y, and you're in slope-intercept form, then you are going to shade above, because the alligator would leave the water to find, something to eat, right? But if the alligator is not going to eat the y, you're going to shade, not above, but below. Now say you think you're going to forget that. Well, luckily there's always a way to check your work. I'm going to show you that now. So the other way to do it is to take those test points that we talked about earlier, like 0, 0, and plug that into the inequality.
Ooh, why?
For x and y. 0 for x and 0 for y. And then what you're going to do is evaluate this. You want a mechanical one?
Yeah.
Mm-hmm. So that's going to be 0 is less than, what's negative 2/3 times 0?
0.
0 minus 1?
Negative 1.
Is 0 less than negative 1?
No.
That's false, right? Therefore, 0, 0 is not in the shaded region. And is that true based on our picture? It is. So you know you shaded correctly. Does that make sense for everyone, what I'm saying by that? Okay. Thank you, Paige. You ready for number 3?
Wait, can you
Sure. Did you forget something?
Thank you.
Welcome. Make sure that door. Alright, let's go ahead and try 3. So the first thing I noticed with 3 is that it's not in slope-intercept form. So the first thing I need to do is to get it into that form by manipulating the inequality. So I'm going to start by subtracting x on both sides. That's going to give me negative 6y is less than negative 1x minus 12. Now when I deal with a minus x, I put the negative 1 there because I think it's a little easier to work with, and you'll see why in the next step. Now to get the y totally by itself, I'm going to need to divide both sides, aka every term, by that negative 6. And does anyone remember from algebra what happens to your inequality sign when you divide by a negative?
Flips.
It flips. So see how I divided over the inequality by a negative number? That is the only time that you flip the inequality sign, and it happens every time. What is a negative divided by a negative?
Positive.
So this becomes a positive 1/6 x. And remember, you want your slope in a fraction. And then what is negative 12 divided by negative 6?
Positive 2.
Good. So we're going to now proceed the same way we did before. We're going to start by plotting our y-intercept at positive 2. And then our slope tells us rise over run. So we go up 1 and over 1, 2, 3, 4, 5, 6. Now this is sometimes going to happen where you're going to run out of room on the graph, but the other side of the graph has some room. So what you can also do is go the exact opposite in both directions. Down 1 and to the left 6. 1, 2, 3, 4, 5, 6. And you'll see that continues the same pattern for your line. Now, is this going to be solid or dashed?
Dash.
Good, because of the inequality sign. That's not good. There we go. That's better, kind of. So once you have your line drawn, you're going to determine the shading direction. So is the alligator eating the y? when it eats the y, it has to come out of the water. You're going to shade above. And like I said, you can also do the point test too. Yeah.
So in like the last problem, the alligator, you said it's like the sign is the same way in both problems.
In the beginning, but then in the end, this one changed, right?
Oh, okay. Sorry.
That's okay. Does that make sense?
Yeah.
Okay. So is everyone good with number 3? Okay. Let's do number 4. So on number 4, we once again need to get it into what form again?
Slope-intercept.
Good. We got to get it into slope-intercept to work with it. So the first thing I'm going to do is subtract 9x on both sides. That's going to give me 12y is greater than or equal to negative 9x minus 60. Yes. Then what am I going to do?
Divide by 12.
Good. Divide everything by 12. The fraction negative 9/12 will reduce to what? Oops, I'm sorry. Hang on. It just jumped. So this is going to reduce to negative 3/4, right? I can divide the top and bottom by 3. And then how many times does 12 go into negative 60?
5 times.
Good, so it's a negative 5. So that's how you get it into slope-intercept form. Now you plot the y-intercept. 1, 2, 3, 4, 5. Then we go down 3 and to the right 4. 1, 2, 3. 1, 2, 3, 4. Now as you can see, we're out of room, so I know my line's going to continue this way. So I can go up 3, 1, 2, 3, and to the left 4. 1, 2, 3, 4. Solid or dashed line?
Solid.
Good. Shading above or below?
Below.
Above.
Oh.
Because y is being eaten. Okay. Any questions about number 4? Alright. Let's go ahead and try number 5 then. So number 5 is actually an inequality that represents what we would call a undefined line. It's not a horizontal line, but it's actually a vertical. So I want you to think of it as how we would graph the line x equals negative 4. That's how you graph the line portion of this. And everyone remembers, maybe, when you have x equals a number, it is always a vertical line. When you have y equals a number, it is always a horizontal line. So the reason that x is a vertical line is because we have to find the x value of negative 4, which is over here. 1, 2, 3, 4. Negative 4, of course. And what that means is basically every single point on this vertical line contains the x coordinate of negative 4, right? Because this is negative 4, 1, negative 4, 2, negative 4, 3. That's why it's a vertical line, because it contains all of the values that have x of negative 4 in the x coordinate. So now we determine if this is going to be horizontal, not horizontal, shaded or dashed. Solid or dashed? What do you think?
Dashed.
It is dashed. And it's dashed because the inequality sign doesn't have an equals underneath it. So this is going to be a vertical line. I'm going to get it as close as I can here. It's not going to be perfect, but a vertical line that goes through this value. It should be right on it. It's just not cooperating quite right. So then from here, now you can't shade above or below because this one doesn't have above or below. So you have to think logically. what values of x are going to be less than negative 4? The ones on the left or the ones on the right?
The ones on the left.
These points on the left are going to be values that are less than negative 4. They satisfy the inequality. So you can take a point, plug it in, and ensure that's right. So how does everyone feel about 2 through 5?
Good.
Pretty good about graphing? This is a refresh from an Algebra 1 standard, so it isn't your first time learning it. But it's been a while, so. So now we're going to try a real world problem. So it says, John sells t-shirts, plain shirts cost $5, and graphic shirts cost $7. He must make at least $1,200 to cover his product cost. Write an inequality that represents this situation. So, we need to assign variables to each of these scenarios. So I'm going to say that the amount of plain shirts is going to be denoted by the value x, and the amount of graphic shirts is going to be denoted by the letter y. So how this works is as follows. If you want to know how much money you made off of plain shirts, you would take the amount of plain shirts you sold and multiply it by the amount that it costed, right? Which is 5x. And then, if you want to know how much you made off of graphic shirts, you would take the amount that each one cost, which is $7, and multiply it by the amount of graphic shirts that you sold, which is considered by y. Okay? Now, if you need to make at least $1,200, this amount that you make off of the shirts has to be
Greater than, sorry, 1,200 has to be less than or equal to, so greater than.
good, greater than or equal to $1,200. So that means the total amount of money made by selling both shirts, that's why it's a sum, has to be greater than or equal to $1,200. So that's the inequality. Now this is in standard form. Now you could manipulate it into slope-intercept, but in this case it's not really necessary to do that. So the next question says, if John sells 150 plain shirts and 60 graphic shirts, will he be able to cover production costs? How could we figure this out?
5 times 150 and 7 times 6.
Good. You would plug those values in for x and y and test it out. And this is something in real life that when companies are trying to figure out prices and production, they have a formula that they actually plug in to ensure that it does come out. Now, when you do the math for this portion here, multiply and add, you get $1,170. And is that amount more than 1,200?
Yes.
No.
No. But only by a little bit.
No, so basically what would happen if he sold this many shirts was he would be short $30. He would have lost $30. So the answer here is no, it doesn't cover production costs. And realistically, if you have a business, your goal is to make a profit, right? So even if you made $1,200, that's not that exciting. You basically just broke even. So obviously it's okay if a business starts out breaking even, but eventually their goal is going to be to make a profit. So that's definitely not what you want. You don't want to lose money. Thank you. I didn't even hear that. If he sells 90 graphic shirts, what is the minimum number of plain shirts he must sell to break even? So in this case, we're only going to plug in for what value? Y. Because Y represents the number of graphic shirts. You're going to plug in for Y and solve for X. So we do the math. That gives me 50. That's not right.
636.
Yeah, I don't know why I was putting. There we go. Okay. And then we subtract. That's what I was thinking of, 570. Divide both sides by 5. And that means x must be greater than or equal to 114. So what does that mean in context of the problem?
You gotta sell at least 114 pictures.
Good, just to break even, right? So that's what that means in the context of the problem. If you only sold 90 graphic, you would have to make that amount up by selling at least 114 plain. And nobody complains if they make more money than they planned, so we don't have to worry about that end of the constriction. Yes. Alright, so what we're going to do now is we have two graphing problems. Instead of me sitting here and doing both with you, what I'm going to do is I'm going to do 8 with you, and then I will let you try 7, with a partner. So you have a short homework today too, so it's not too bad. So I'm going to do 8 with you. So it says Trevor makes $12 per hour babysitting and $8 per hour working at the grocery store. He will need to make at least $600 to buy a new computer. So basically, we're going to call X the amount of hours he works babysitting, and we're going to call Y the amount of hours he works at the grocery store. If we take the amount of hours that he works babysitting and multiply it by his hourly rate of $12, and then we take the amount of money he makes at the grocery store and multiply that by his amount of hours, and we add those two amounts together, that's going to give us what?
12x plus 8y is greater than or equal to 600.
Good, and that basically that amount represents his total income, right? This is his total income right here. So like if you work 2 jobs, well I do, for example, I can find my total income by adding my 2 income prices together, amount that I work and whatnot. So this is very realistic. Now, this amount has to be at least $600. So it has to be greater than or equal to 600, because in this case, you're not going to be mad if you make more money, right? So from here, you're going to solve this for y. So subtract 12x on both sides. That gives me 8y is greater than or equal to negative 12x plus 600. We divide what? Yeah. Both sides by 8. We get y is greater than or equal to
Wait. Okay. I have a question.
yeah,
Wouldn't you flip the sign if you use the 8?
only if you divide by a negative number.
Right. Oh, I think I might have did it wrong.
So what does 12/8 reduce to if I divide the top and bottom by
4.
3/2? Perfect. And then this is 600 divided by 8. Good, 75. So we have a slight problem when we go to graph this. This is my y-intercept, right? Is that going to fit on this graph if I go by ones? Yeah, we got to go by something else like tens. Good point. So let's say we go by tens on this axis right here. So, tens. So I'm going by tens. I'm just only listing every other value just to make it look more neat. But it's the same thing, okay? And then on the bottom here, we can also go by tens. And like I said, I'm only listing every other just to keep it more spaced out. Keep in mind, you can do 2 different axes for each one. Like you can do different scales on each axis if you want to. So what does the x-axis represent? Good, babysitting. And this axis over here represents, good, grocery. So now we're going to go ahead and graph this. So if you keep the scales the same, even though we're going negative 3/2 and these are by tens, you can still keep it consistent because that's like negative 30 over 20, right? So that's okay as long as the scales are the same when you use your slope. So that's going to start at 75, which is somewhere right here between the 80 and the 70. And then we're going to go down 3 units, so kind of weird when you're in the middle. 1, 2, 3, and then over 1, 2 units. Do that again. 1, 2, 3 over 1, 2. And is this going to be solid or dashed?
Solid.
Good. And am I going to shade above or below? Above. So as long as he works in any of these, any point in this green area, he'll have enough money, right?
Yeah.
So now let's look at the last question here. It says, using your graph, give 2 possible combinations of number of hours Trevor can babysit and work in the grocery store to ensure he can afford his new computer. So you can basically pick any point. Like I can pick a point right here, and that point would say that he has to work 30 hours babysitting, and then he would have to work 70 hours grocery. Right? And then you could do that for another point as well. So it's kind of like how if you have 2 jobs and you need a certain amount of money, you can kind of change up which one you work more. Does that make sense to everyone? Okay. So you go ahead and try 7, and then your homework, 1 page, it's only a front page today, is going to be due the 23rd. So try number 7 with a partner if you'd like, and I'll put up the answer in about 10 minutes, maybe 5 minutes.